All right, so I got to remember that I got to stay over in this area. Let me go ahead and I want to create some air because it is kind of stuffy in here. Might help if I unlock the window first. Okay, that seems like it's on. Okay, that's much better. All right, so let me check. Do you really feel anything? I don't feel anything. Okay, I'm going to let that be. I'm going to assume that it's working properly because I really haven't made any changes. So attendance should be coming around. Okay, let's kind of backtrack. So exam 2 grades are posted. There was a huge spectrum. Okay, it was a huge spectrum. There were a few that did well, but it was a big spectrum. Okay.
That's a difference.
Yeah. So you kind of have to decide. You have to kind of make a decision on your own. I mean, it's not so cut and dry because there's all spectrum of kind of scenarios going on. You have people that study that don't do well. That's a classic with college algebra. You have people that don't study and aren't doing well. That's a typical scenario. You have people that don't study and are doing well. That happens. And then there's one more that I'm missing.
Do study and do well.
Yeah, people that do study and do well. Yeah, definitely just said do. But the whole point is, you probably want to track down somebody. I think the best plan of action, find somebody that has not seen this before. I mean, anybody that's doing well, they have something to offer. Everybody has something to offer. People that study and do well, they have something to offer. People that don't study and do well, they actually have something to offer as well, if that makes any sense, because they're going to be able to articulate it better than I can. When I kind of show you all how to do different things, it's going to be information overload a lot of times. With me, when you ask me, you have to have looked at it in advance already. And then when I kind of give you solutions, it'll sink in. But if you come to me first, a lot of times the students are overwhelmed. Okay? So I want you to also kind of be aware that in mathematics, just because you study is not a guarantee that you'll be successful. But on the flip side, if you don't study, you're almost guaranteed to fail. Does that make sense? So it's just one of those things. College algebra, at this point on the journey, it should be clear that if you don't like the kind of scores that you're getting, you got to do something different. If not studying has not been working, you got to do something different. No, on the real. Even if you're studying and it's not working, you got to still change something up. Usually the way it goes, I want to say for the traditional, not ideal, just traditional student, because there's not really an ideal. There's not really a good or bad. It just is what it is. But like the most people are successful where it goes. They might come in not knowing anything, but then they study. They do what they can on their own. Then once they got to that point of not being able to figure it out, they team up with their classmates, right? They're going to get with people, exchange contacts, and like, hey, I was working this, I got stuck. When you work with your classmates, actually, you all teach each other way better than I can. When I teach it, again, it's typically information overload. There's a lot of anxiety. I know students tend to have a hard time. But if you ask me, I'm just trying to all right, but yeah, but that doesn't mean I'm not willing to help. So, make use of, this is why I was kind of encouraging everyone to use the MyMathLab, right? We have it set up for it to be free, so everybody should be able to get free access to that. You want to be working through those and make use of that Ask My Instructor. When I make dedicated videos for specific questions, I go at a completely different pace than I do in class. I know class is one rhythm. I'm trying to touch on each concept with a little bit of time that we have together. When I do dedicated videos outside of class, that's a completely different rhythm. It's a lot slower. Excuse me. It's a lot slower. Yeah, it's funny. It was hilarious. But it's a lot slower, and you can pause the video, you can rewind, you can do a lot with it, So make use of the Ask My Instructor that's on MyMathLab. That's why I keep pushing it. So the order that it goes, you do what you can on your own. You got to be genuine. You cannot hide. You cannot hide. Nobody can hide from me in this class. I don't say anything. I don't ask because I already know. Okay, so I can tell by confidence, energy, grades, questions, the whole experience. I already know what's going on, so that's why I don't ask anymore, because I'm not trying to hound anybody or anything like that. As far as I'm concerned, you all are adults. If you feel like you can finesse this, you cannot. First of all, you cannot finesse mathematics. You just can't. You can try. It's going to catch up with you sooner or later, and it's a lot of times it's sooner. But that's not a bad thing. That's not a bad thing. It's just you got to snap out of it quick, fast, and in a hurry. So again, the way it usually goes, you do what you can on your own until you get to that frustration. You want to be frustrated a little bit. You do not want to be comfortable. If you're comfortable, just like in life, you don't want to be comfortable. Because when you're comfortable, that's when you get stale. That's when you get flabby. That's when you get dull. That's when you lose your senses. So comfortable is okay in small little spurts, but don't get comfortable with being comfortable. You want to be uncomfortable. So if you're uncomfortable, that's a good sign. That's a sign saying, hey, you're on the precipice of growth. Growth is right knocking at the door. You see what I'm saying? So first thing is, do what you can on your own. You got to be a little bit frustrated. You got to be frustrated a little bit. So it's okay to be stuck for a while, but don't stay stuck. Don't stay there. Be there a little bit and like, okay, wait a minute. If you feel yourself getting into a rut, just put it down for a moment. Go eat, go rest, get outside, go play. This is why I do games, because mathematics as a beast in and of itself, it can really kind of bog you into this weird little emotional state. So that's why I'm constantly doing games and being in nature and stuff like that to keep my energy and my spirits high. So now, you do what you can on your own, you're stuck. Now, once you've gotten out of that rut, you team up with others. Now when you team up with your classmates, especially people that are genuine, you're like, hey, when I was working it, this is as far as I got. They'll be like, oh, this is all you got to do. And they're going to say it just like that, and it's going to click. But if they came at you like that from the beginning and you didn't study or practice, it's not going to click. You see what I'm saying? So you got to be frustrated a little bit. Then when you team up with your classmates and your peers, then that'll get you to another level. Then beyond your classmates and peers, then you go to tutors. So now I know that you all, are in high school. So getting back to this location can be a challenge, but we're in the information age. So if you really want to find the information is there, think about it. If there was some event going on and you needed to get there, you would find a way, right? If there was some food or restaurant you want to go to or a movie, whatever it is, if it's entertainment, something that's fun, if you really wanted it, you're going to find a way. You got to do the same thing with this. You got to. You got to take that same drive and apply it to this concept, this information. So again, that's called manifest destiny. We will get whatever we're looking for. So you got to be looking for it. If you're not looking for it, you're not going to see it. It's called manifest destiny. Okay, so you've done what you can on your own. You've been frustrated a little bit. You've teamed up with your classmates. Now, as a group, if you got to that point and you can't go further as a group, that's where the tutors come into play. And I'm at least an online tutor for free. Even if you have to pay, you don't have to pay because the school offers free tutors here on campus. So, there are YouTube videos. That's why I'm building up to that. So I actually make dedicated YouTube videos. There are videos explaining how to do the different concepts. The MyMathLab explains how to do each and every question. Each and every question. They walk you through it. So you're doing what you can on your own. You've teamed up. Then you hit a tutor. After exhausting all of those resources, that is the ideal time to come to the professor. You can come before, but then it can be information overload. Now when you come and I give the exact same presentation, when I say it, you'll be like, oh, I get it now. You're going to get it. But that's the order that it usually goes in. And again, I'm not going to hound you all. I'm going to treat you like an adult. Again, this stuff is not difficult. It's really about your ability to time management, prepare in advance, kind of space things out, organize yourself, and, take charge of your emotional state. Don't get down, but you got to be savvy. You do got to be smart. Now, we've had 2 exams. I would say you can anticipate at least 1 more exam in the final. Let's go to Moodle really quickly. So if we go to Moodle, right, today is February 13th. So we are in I think we're in week 5. We should be in week 5. Yes. We're in week 5. So week 6 next week, we definitely need to do the assessment. We'll do that in class. It's a good idea to bring, if you have a laptop or a tablet or something like that, you want to bring that to class, okay? So next week we'll do an assessment in class. I would say go ahead and anticipate exam 3 over the first half of chapter 2. I really want to do that next Wednesday. More than likely, let me see. We're going to be here Friday, but I think Monday's a holiday. So more than likely, we're not going to do exam 3 on Wednesday. More than likely, it'll be the following Monday. Okay, but anticipate exam 3 over the first half of chapter 2. Okay. So then what else is it? So now you've done what you can of your own. You've teamed up. You've gone to a tutor, and then you hit the professor. Usually by the end of that, That's usually what it takes. And then somewhere along that spectrum, it should start to click.
My sister's a math teacher.
Okay, so maybe y'all might want to team up with her sister
She got me in calculus.
because you definitely want to get another perspective. You definitely want to get another perspective. This is all about visualization. Excuse me. Thank you. Hey, thanks. Yeah, because I'm raising my volume trying to talk over it because I'm listening to you all. So again, my only request is minimize the distractions. I can't think of anything else. Okay. You can also hit up. I think we have at least one or two other professors here on campus. So if I can be a little intense, go to another math professor and say, hey, I'm taking this course. Do you mind helping me a little bit? They might try to redirect it to me, and that's fine. But you just want as many perspectives as you can get. Okay. I'm trying to think. I can't think of anything else. Oh, and you do want to be a little savvy. So it's probably a good idea. Go ahead and take exam 3, and then you have to make a decision from there. But now, I think a lot of you don't really have a choice in the matter. But if you do have a choice, maybe after exam 3, you might want to kind of make some real decisions. But I will say that there will be opportunities. So, I usually do my best to try to take care of people in my class, but it's not a guarantee. There are no guarantees with any of this. All I'm really doing is recording, and then I try to help where I can. I can only take what you guys give me and then kind of go from there. But I don't really give grades. I record what you all are doing. Okay, so that's just like a little snapshot. And I'm having this conversation because I want our people online to hear the same conversation. Because it's a good amount of people in the same boat. So don't ever feel like you're alone. Don't ever feel like an isolated. This is why it's important that you're talking to your classmates. You've got to team up. That's at this level, that's a strong thing to be able to team up and work together. Okay? So, and don't ever feel like you're alone. Don't ever feel isolated because you're not alone. It's a lot of people in class. Go ahead.
Can I see what I got wrong so I can be able to ask for help?
Yes. Remind me at the end of class. I actually have the originals. They're in my office. I have to get them out of the office. So,
You have an office?
yes, it's right across the way. I have office hours and everything. I don't know if you all can come back on Tuesdays and Thursdays, but I'm usually here. And even if I'm not, if you email me, I will be here. So, but I'm usually here on Tuesdays and Thursdays during office hours. You want to make use of that, but I know it's a little bit difficult for a lot of you all to travel, but just stay in contact. Email me and we'll work it out. I have time. I'm available. But yeah, so just remind me at the end of class. I can get out of my office and we can look at it. So I try to stop a little bit early. Go ahead.
We have a different class.
Yeah, so I'll try to stop a little early so that we can do this. So about 1 o'clock, I'll try to wrap it up or so. Okay. Any other questions, comments, or concerns? Okay. So exam 2 grades are loaded again. To have something we never had before, we must do something we've never done before. Doing the same thing over and over and expecting a different result is the definition of insanity. So in order to see a different result, we got to do something different. I don't know what it is, but something different has to be done. All right. So today we need to get through section 2.1 idealistically. If we can get through 2.1, we'll be sitting pretty. Sitting pretty. All right. So that's neither here nor there, and even when I was saying you can't hide, that applies to me too. I can't hide from my stuff. I try to stand by my actions. I'm a human just like everybody else. So I make mistakes, and we're all just spiritual beings having a human experience. So there's no ill will on my end. Again, I'm just acting as a facilitator. The other thing is, don't read too much into this academic thing. It's just a thing. It's not anything. There are so many cases where people have no training whatsoever, no academic. They failed their grades. They did all this stuff, whatever you consider to be the worst thing, and they're doing much better than any of us. They got money. They're free. They can travel. They're happy. So don't read too much into this. Do your best. Forget the rest. Don't stress and be blessed. You see what I'm saying? And you have to know that in the long run. Look, I can't help it. See? You see? Repetition is key. She said, you know how many times he said that? But then I just got to request to say it again. But again, do your best, forget the rest, don't stress and be blessed. Because in the long run, everything is going to be okay. And if everything is not okay, that means it's not yet the end. Anyway, so scratch all that. So now let's get into today's lecture. So today we're looking at section 2.1, rectangular coordinates and graphs. We're just going to jump into it. Okay, so an ordered pair. It's a pair of components written inside parentheses, and the order is important. if we change the order, so like if I were to write something like this, like if I wrote 2 comma negative 3, what does this mean based on the context that you see on the screen? X and Y, right? What's our X value here? 2, and what's our Y? Now, what if I did the following? You know, if I said, what if I did this? What's our X now? Negative 3, and what's our Y? I'm trying to let the train pass. Okay, so this is like our X, this is a Y. I think most people, that's okay with most people. Is this okay? Any questions, comments, or concerns? And another good idea for my class in particular, have a copy of your old exams. Make sure you know how to work all those old questions. You don't be fooled by the same question again. In other words, what I'm saying, it's a good chance that you can see some of those again in my class on the final exam. You see what I'm saying? So it's a good idea to take your old exams. You want to get them corrected. Make sure that you know how to, at a minimum, at least know how to work all the questions on your old exams. If I ever give you a study guide, at least know how to work every question on the study guide. That's not everything that you need, but at a minimum, these are things that you want to do for a math class. All right. So, but notice, when we changed the order, that changed what the X and what the Y values were, okay? All right, I'm going to keep moving. All right. Use the table to write the order pairs to express the relationship between blah, blah, blah. Oh. Okay, so now when we're talking about food, if we wrote an order pair with food, what gets associated with food? How much money was spent? Right, and then housing goes with the 17,000, so on and so on, right? So I think that all is straightforward. Housing goes with the 17, so on and so on. Any questions there? Am I going too fast? Go ahead.
So I've always been kind of confused, but you know how you gotta work on it, you gotta figure out which component is X and which is Y. They said X is the independent variable and all that. How do you know?
So, well, a lot of it is context. It is based on the context. But then this is just me personally, as opposed to me not personally, whatever. But when I translate from word problems to variables, I don't like to just use X because it's not relatable. So when I start doing word problems, I'll use a label that has some relevance. Like if we're talking about number of apples sold, I'll put an A for apples instead of X. So that whenever I see the A in my mind, it triggers, hey, we're talking about apples or whatever. So the labeling in your organization is a big part of that. And then once you kind of have drawn everything out, you draw pictures, you label it properly, you write everything down, and then you just got to be clear, and then kind of take your time. You have to read it several times, and then you just do your best to get the rest of that whole jazz. Okay? So that's the kind, and you'll see it in action. All right. I think this is okay. How many quadrants are here? 4. Where's quadrant 1 in the upper what?
Right.
Upper right. And then which way does it go? Does it go clockwise or counterclockwise? Counterclockwise, right? So give me a color. I heard blue. And we're just going to do the blue for down. Right? Okay. So here's quadrant 1. And it goes counterclockwise because it goes the opposite direction of the hands on the clock. So here's 1, here's 2, here's 3, and then 4. Right? So whenever we plot ordered pairs, we start at the origin. What do I mean by origin? 0, 0, or the center. And then positive X is going to the right, negative X is to the left. Positive Y is going up, negative Y is going down. All right? And so when they give us the ordered pair, we start at the origin. The X tells us left and right. The Y tells us up and down, and then we'll get a point. Okay? All right, I'm going to keep moving. The distance formula. Anybody know where the distance formula comes from? What basic shape do you see on the screen? What kind of triangle? Okay, so yeah, I agree. This is a right triangle, and so the distance formula comes out of the Pythagorean theorem. Yes. Yes. Again, of course, you're in my presence. I only attract like-minded individuals. I know I'm a genius, so I know who you are. Okay? Game recognized game. So, and you're looking familiar. So, anyway. So, yeah, this is good. So, now the distance formula. If we want the distance between P and R, let me see. So, let's look at P and Q. Can I paste? No? Okay. We're going to go here and like that. All right. So, here's P. Here's Q. We want the distance. So, what's the X value here? What's the X value here? If we want the distance from -4 to 8, what do we do? Okay, what are we saying? What minus what?
Y2 minus, I mean,
Yeah.
X2 minus,
Yeah.
well, it's Y2.
No. You got to write the x2 is right.
Yeah.
Okay, so x2 minus x1. So we're going to say what minus what in this case? Okay, 8 minus negative 4. So double negative becomes,
8 plus 4.
which is
12.
12, right? So this one will have a distance of 12. So if we were to count, if this is negative 4, there's 4 to get back to 0, and then 8 more to get over here. 8 plus 4 is 12. If we said 8 minus negative 4, we're taking the absolute value because we're doing distance, so we take the absolute value, right? Long story short, that distance is 12, right? What about on the side over here? What's the y value here?
3.
What's the y value here? What's that distance?
5.
So we said 3 minus negative 2 is double negative becomes positive. We get a 5. We take the absolute value. We could also do negative 2 minus 3. What's negative 2 minus 3? Negative 5. We take the absolute value of negative 5. We still get a positive 5. Okay? So now we got this side. We got this side. So now we know what? A squared plus B squared equals C squared. We can solve for that missing side. Right? So the distance formula comes out of the Pythagorean theorem. All right? So if we want the vertical side, again, absolute value 3 minus negative 2, we get 5. And so then we get, so the horizontal, the hypotenuse is going to be, have a unit, 13 units. Okay? But again, the distance formula, so the distance between P and R in this case is 13 units. So again, this formula comes out of Pythagorean theorem. If we label, say this is our side A, this is our B, and this is our C. Well, we said that A just a minute ago was what? X2 minus X1, is that right? So this is X2 minus X1, come on, X1. We're going to do absolute value. B is going to be what? Y2 minus Y1, absolute value. Yeah. So let's do this. If this is our B, and what I'm going to do is shrink this down to size. All right, and I notice a little bit. Oh, come on. All right, but that's B over there. So then when we apply Pythagorean theorem, if we do A squared plus B squared equals C squared, when we square an absolute value is the same as what you see as the final result. So an absolute value squared essentially is the same as what you see. When we use a distance formula, we just want to be consistent in our ordering. So if we say x2 minus x1, then we need to do y2 minus y1. We don't want to do x2 minus x1 and then y1 minus y2. That might throw things off. You see what I'm saying? So if the 2 comes first on the x's, the 2 needs to come first on the y's. Just be consistent, you know. Okay. So this formula, you should commit it to memory. Again, we're going to do open notes on our exam. So if you have your formula sheet, this is one of those formulas you want to add to your formula sheet and just have it ready to go. So you don't have to do a lot of flipping and searching and stuff. All right, so my clock, life flag, I keep knocking it over. 12:20. Okay, so we're okay. I'm going to keep moving. All right. So yeah, given 2 points, we want the distance between any 2 points on the coordinate plane. Again, distance formula. So again, this, you should commit it to memory. I'm not going to make you remember it. You just need to know how to use it for my course. But if you go to any other math course, they're going to expect you to know this. So this is one of those formulas you definitely want to commit to memory. But again, it comes out of the Pythagorean theorem. Okay? It comes out of the Pythagorean theorem. All right, I'm going to keep moving. I'm just going to use, if it unfreezes, I'm just going to use what we already have. So find the distance between these 2 points. Okay, so whenever I know I'm going to use a distance formula, I just automatically do the following. I'll go x1, y1, then I'll go x2, y2, just automatically. That works at least 90% of the time, at least for this class. Just go ahead and label it. Now when you go to use the formula, it's easy. You just plug in the corresponding components. What is our x2? Okay, well, yeah, I see where it's not working for that one. But, oh, no, it's working. Scratch that. Yeah, we're fine. X2 is 3. What's X1? What's Y2? So on and so on. Is that okay? So I just did X1, Y1, X2, Y2, and then usually it works. Okay? So then once we plug the corresponding components into the formula, then we just crunch the number. We eventually get to here. So you want to, what's a good idea? You want to start with this original. Start here and just, you want to find the distance between those two. See if you can get to the same conclusion without checking the notes. So use the formula, do your labels. See if you're going to arrive to the same conclusion. Don't just look at it. You know, take an active role in the experience. Okay, I'm going to move forward. Questions, comments, or concerns? Are we all aboard or are we all bored?
Bored.
See, I was going to give extra credit, but now we're all bored.
I said all aboard.
All right. I just messed. I was. It didn't matter what you were saying. I was gonna find some way to try to make you feel bad for it. It didn't matter what you said. Okay. So now the distance formula. Okay, if the sides A, B, and C of a triangle satisfy A squared plus B squared equals C squared. Again, this is supposed to be squared. Now these are typos. That's just the way it printed. It's supposed to be this. So then the triangle's a right triangle with the legs having lengths A and B with the hypotenuse of length C. So now again, if we have a triangle that satisfies A squared plus B squared equals C squared, that means it is a right triangle, and vice versa. You can go back and forth with this. So what I mean is, like, you can be given the size of a triangle. We verify that it matches A squared plus B squared equals C squared. Then that means that it's a right triangle. Conversely, if we were given that a triangle is right, we can apply this formula. Yeah, so we can go either direction. All right, I'm going to keep moving. So then the question says, are these points the vertices of a right triangle? So what did we just say? To verify, if we're given 3 points, if we can verify what? That the sides are satisfy A squared plus B squared equals C squared. So like if we just did a quick sketch, let's go like this. I'm just doing a quick sketch. So we're -2 and 5. So say this was M, right? This is -2, 5. Over 12 and up 3 is about here. This is going to be our N at 12, 3. And then over 10 and down 11 is somewhere about here.
So basically, if it makes the right triangle, then that's
right. 10, 11, right?
I feel like I always get it sometimes.
Yeah, that happens. That's the nature of the beast.
Right.
Well, it's not drawn to scale, but we have to verify it. So what we have to check, we just maybe label this as, we could say this is side Q. This can be side little m and side little n. So then we just need to find M, PQ, M, N, and Q, whatever. O, P, Q, R, S. Yeah, M, N, whatever. M, N, and Q. Find those sides. So how are we going to find those orange sides? Use the, we want to verify that those match the Pythagorean theorem. But for instance, what's the length of little m, the orange m? Use a distance formula. So we have to use a distance formula 3 times to find the orange parts. We get those numbers and then see if they verify the Pythagorean theorem. So it's like it's a loaded question. Yeah, it's loaded. So when they gave the 3 points, first we have to use a distance formula to find all those sides, then see if they satisfy the Pythagorean theorem. Okay, so it's a loaded question. So let's look at it. So that's all that they're saying there. So they plot it. Okay, so now the distance from M to N, right here. So M to N, this distance. So we said what? X2 minus X1. So this minus this, you see it there. This minus that. All right. So you have the distance formula, you write it out, you get something like this. So this one is going to be the square root of 200. All right? It's cut. If we did M to Q here. So again, just use the distance formula. Once you get it once, it's the same thing repeated. You can use your calculator. You just want to make sure you can produce these numbers. This one is 20. This one was square root of 200. All right, so here we got the square root of 200. This one we got 20. Or I'm going to say the square root of 400 equal to 20. And then if we look at the last one, can we paste? Into Q, if you do the distance formula, we get 200. So we got square root of, square root of 200. We got the square root of 200. We got the square root of 400. So you want to verify that we can get these results. So then, in order for this triangle to be right, what needs to be the case? A squared plus B squared needs to equal C squared, right?
It does not.
Yeah.
It's not even a right triangle.
But square root of 200 plus square root of 200 is square root of 400.
Uh,
No?
close, close. It's almost. So 200, right, squared. 200. You see the difference? Is that true or false?
It seems like it's true.
True.
I think it's, yeah. I was like, it's confusing me. I'm always saying false. The square root and to the second cancel out all of them. Even though that's not a right triangle.
Because it's not drawn to scale, but if you actually drew it to scale, it is a 90 degree because it satisfies the Pythagorean theorem. Does that make sense? Okay, yeah. Well, don't, yeah, okay. Well, yeah. So, I mean, it's a good thing we're having this conversation because if we didn't bring it to people's attention, yeah, you get on an exam and do that, that's a good way to be led astray. All right, I'm going to keep moving. Okay, we're about halfway through this, and that's a good rhythm. And my time, we're okay. All right. Yeah, so we verified this already. So it worked out. Okay, collinear. If you see co, like where have you seen the prefix co?
Cooperative.
Cooperative, right? What does that mean? Cooperate. What does that mean? Together, right? Yeah, right? Together. Where have you seen co again? What's another? Co what? Co. Okay, with efficiency, yeah. Covalent, so a bond. Chemistry, yeah. Covalent bonds. With coworkers, what I was thinking. Yeah, so the prefix co. So, you know, these are people that you work together. You work with these people. So co, it means the same thing in this context. So when you see linear and co, so collinear means that these are on the same line. They work together on the same line, right? So we can tell if 3 points are collinear if they lie on a straight line using a similar procedure. 3 points are collinear if the sum of the distance between the two pairs of points is equal to the distance between the remaining points. What we mean by that, say we have 3 points, this, and something like this, right? Say this was A, B, and C. So the claim is that these points are collinear if, say, this is 1, 2, and then 3 was it from end to end, right? So we're saying that these 3 points are collinear if the distance of segment 1 plus the distance of segment 2 equals the distance of segment 3. That's what we're saying. Does that make sense? 3 points are collinear if the sum of the two pairs is equal to the distance between the remaining pairs. Yes. Okay? So to test whether 3 points are collinear, basically segment 1, if segment 1 plus segment 2 equals segment 3, then we say that the points are collinear. Else, they are not collinear. Does that make sense? Okay, I'm going to let that be. I'm going to move forward. So when we're saying collinear, notice we have the points A, B, and C. So if it's the case that segment 1 plus segment 2 equals segment 3, then the 3 points are collinear. But if that's not the case, then they are not collinear. Then they're not on the same line. Distance formula 3 times. Yeah. So that's another loaded question. Yep. Okay. Mm-hmm. Yeah, we have to do the distance formula 3 times. I'm actually doing much better. This morning when I first got to class, I was like in so much pain. I had this headache. I had a long night. Was up. I woke up like a weird hour. I didn't go back to sleep. And when I finally went back to sleep, what happens? Of course, it's time to get up. Alarm goes off. So I had this super headache. I knew I needed just to eat and sleep. But after I got through my first class, it all went away. I don't know if I was like a zombie and I was asleep while talking at the same time, because that happens to me a lot. But anyway, okay, I'm going to keep moving forward. Questions, comments, or concerns? All right. All right. So again, as much as I would like to take class time for us to like work problems together, we just don't have the time in class to do it. This is why you have to work it at home. And you know, math is all about repetition. Math, the proof is in the pudding. Repetition is the key. Go ahead. What we do the longest, we do the strongest. Go ahead.
That's also I was at this class. We,
Well, in the past, when I first started here, we actually did have classes that went for 3 hours. It was grueling. It was grueling. Like, yeah, it was grueling. I mean, because we would have lecture and we would do it, but imagine after about 20 minutes of me with this intensity and this topic, people are like floored, right? Imagine that for 3 hours.
No, we can imagine. We had 3 hours.
So,
Math for 3 hours.
yeah, math for 3 hours is a bit much. So, what you have to do is, you have to do it in spurts. Now, for me, I know when I was a student doing math, the best time I did math was when I first woke up. When I tried to do it, like when I first get home, I'm exhausted from the day, I'm hungry. So I would kind of chill for a bit. I would go to sleep, and then I would wake up naturally, and I wake up at like 8 or 9 or something like that. That's when I would do all my math. As soon as I wake up, that's when I would do it and go until go kind of hard or whatever. So you have to be wise about it. You have to kind of plan accordingly. So then this question says, are these 3 points collinear? So now we're not going to plot them. I mean, we could plot them. If I did a quick sketch, give me a color. I think I heard green because I did purple already. I'm going to do the
Purple a lot.
Yeah, I always think royalty when I think purple. Pardon?
Or black.
I just not using black because the text is in black, so I'm trying to get something that pops a little bit.
And you don't put yellow.
Well, yellow because on my tablet I can't see it. I know you can see it on the screen, but I can't see it. Yeah. Okay. So now if we go back 1 and down 5, we're about here. So this is -1, 5. This is P. Over 2 and down 4 is about here. So this is 2, -4. This is Q. Over 4 and down 10. 4, 10, looks like it's about... Oh, I did the first one wrong, right? This is supposed to be up here, 5, right? Over 4 and down 10 is about here. Oh. And this is 4, -10, and this is our R. All right, so now it's not drawn to scale. We can't just eyeball it. We need to verify, all right? So if we had this segment, we're going to do 1, 2, and then 3 is going to be the whole thing. Okay. All right, let's see. So now, if we can show that segment 1 plus segment 2 equals segment 3, then we can say yes. If it's not equal, then we can say no. Does that make sense? Well, it's not drawn to scale. I didn't use a grid. It could, it could actually be there. Yeah. I don't know why I'm engaging. I'm still kind of a zombie. All right. So we need to verify that 1 plus 2 indeed equals 3. So when we're doing segment 1, that's what? P to Q, right? So you see it right there in the distance formula. So P to Q was 3 times the square root of 10. Point P, oh, and I just didn't draw it properly. So let's move this. This is actually right there. And then Q is, now. Q is, I know I got the wrong thing. Come on. Q was that point right there. It's that, and this, nope. Let's try again. We want these guys, and we want this, and we got to get back. Oh, we got it. And this is Q. That point that's next to the Q. And then R is down here. So yeah, I just need to kind of clean up my drawing. Okay. So yeah, we need to verify that segment 1 plus segment 2 equals segment 3. So long story short, we're going to do the distance formula 3 times. So P to Q was 3 root 10. QR is 2 root 10. And P to R is 5 root 10. So is it the case that 1 plus 2 equals 3, yes or no? Yeah. How do we say 3 root 10 plus 2 root 10? What does that become? So in order to add radicals, what has to happen? Same radical, right? So they have to be the same. You got I know you all can see it. I know the terminology is a little off, but I know you can see it. So when I say radical, we're saying the same index and the same radicand. What's the index on the square root of 10? What's the index? 2. What's the radicand for the square root of 10? 10, right? So you have the 10. 10. So the radical has to be the exact same in order to add and subtract radicals. It's just like combine like terms. Combine like terms. So yeah, it checks out. So yes, the 3 points are collinears. Okay. All right. Thank you. All right. Ooh, I'm about to fade. I want to just like lay my head down and take a nap. Pardon? Okay. Pardon? What about it? You can't use it? Okay, so the instructions for MyMathLab, I had to delete it and load it from scratch. There's a PDF. Mm-hmm. It's still not working? A new account with a new email. Yeah, you got to register. Yeah. Yep. Let's look at it a little bit later. Like I'm trying to stop around 1. The time is, so we got about 20 minutes. Yeah, we kind of got to keep moving. So once I finish this section, we'll do that kind of housekeeping stuff. Look at some old exams. You know, we can look at all that kind of stuff. Okay, let's keep moving. So the midpoint formula. Really quickly, if I had, say I'm the professor, and I know, all right, and I have 6 exams. If I add up the 6 scores and divide by 6, what am I finding? Average, right? So midpoint is nothing but the average of your x's, comma average of the y's. So if we have 2 points, if we want to find the midpoint or halfway between those 2 points, average of the x's, comma average of the y's. So the midpoint, so say we have a point P and a point Q. The point that's halfway between those, we're going to take the average of the x's, comma average of the y's. That's the midpoint. All right? So let's look at it in action. Find the midpoint between these 2 points. So now again, we have an ordered pair. I'm just going to automatically do the following. I'm going to say x1, y1, x2, y2, right? Y2, right? So now if we say average of the x's, we're going to say 8 plus negative 6 divided by 2. Average of the y's, we're going to say negative 4 plus 1 divided by 2. Then we get our result. That's going to be halfway between those 2 original points. Okay, any questions? Are we okay, ladies? Ladies, can we reduce the volume some back there? Okay, any questions? Ladies? Thank you. Thanks. Okay. All right. We're going to keep moving. We're almost done, and we'll probably stop at the end of this section. Didn't want to see the solution, but that's okay. Okay, now we're asked to find the coordinates. There's a train. Find the coordinates of the other endpoints Q of a segment with one endpoint is P and given this midpoint, right? So we're going to do a quick sketch. Give me a color.
Aqua.
When you say aqua, are you referring to like this one? Is that one, the other one? You mean like this one? You think mean like green?
Go up and over
This is aqua to you?
It's more aqua than what you said.
I feel like this is like, I guess you have an aqua blue, aqua green, aquamarine, something. So I guess okay. All right. So let's do a quick sketch. This is just a rough sketch, right? So P is back 6 and up 12. So it's somewhere about here. You're gonna load. P, we said negative 6, 12, right? P. The midpoint, so we have some midpoint, is over 8 and down 2, so that's about here. This is the midpoint. This is 8, negative 2. So if that's the midpoint, we're anticipating some point. I'm going to change the color just so it pops a little bit. It's about here. This is going to be some x, y. Let's clean that up a bit. It's going to be some x, y, right? So because we don't know that one. All right, so then the midpoint formula goes as follows. Let's do it like this. So x, y equals what? X. Average of the x's, average of the y's, right? That's not proper labeling. Let's do this. So our midpoint, let's see, m1, m2, maybe, or let's do it like this. Mx, my. So the midpoint, the x coordinate of the midpoint, the y coordinate of the midpoint, x1 plus x2 over 2, y1 plus y2 over 2, right? So what's the x coordinate of our midpoint? What's the x coordinate of our midpoint? What is it? 8, right? So 8 is the x coordinate of our midpoint. What's the y coordinate of our midpoint? Negative 2. That should be equal to, what's x1? Negative 6. What's x2? Okay, based on the way you have it drawn, it's going to be x. What's y1? 12, right? What's y2? Y. Okay. So what would you do with these two results, or these two order pairs? Mm-mm. So the left order pair equals the right order pair if, when x is 8, not plug it in, but set them equal to each other. We're saying these two ordered pairs are equal, so that what we're saying is that 8 has to equal the 6 plus x over 2, and negative 2 has to equal 12 plus y over 2. Does that make sense? We align the corresponding components. All right? So then from there, we should be able to solve. All right. Okay, so not trivial. You know, I'm just showing you, you know, some of the options. So also, you know, this field of mathematics, it tends to be like a collection of tricks. Like we have the baseline structure, and then to work a lot of the problems, it's always some kind of gimmick or a trick or some kind of manipulation. And a lot of times it's not natural to think that way, but the only way you're going to think that way is by exposure. You're only going to know because, oh, in the homework, well, this was the trick for the homework and stuff like that. But again, you're only going to know it because you got to be looking for it. And once you see it, you're like, oh yeah, this is how we did this before. But if you know, if you haven't seen it before you get to the exam, you're not going to know, and I'm not going to be able to explain it to you. So, but again, so like in this first one, to kind of help to drive it home a little bit better, give me a color. Red. Okay. So what I mean is, I probably could have done a little bit different. You see that? How that matched up? Give me another color. Brown. Is that better? So the left order pair, in order to equal the right order pair, the red has to equal the red, the brown has to equal the brown. Is that clear? Mm-hmm. That'll give us the coordinates of the missing piece. Okay, so we had one order pair equals another, so we matched the reds together, we matched the browns together. Okay, this is why I like this device. It's easy to kind of edit and manipulate and things like that. All right, let's keep moving. So from that point on, you should be able to solve for x and y, 22 and negative 16. Those are going to be the other endpoint. Yeah. All right, we're almost there. Let me see. Let's just keep moving. All right. So this example, it says the following figure depicts how a graph might indicate the increase in revenue generated by a fast food restaurant in the U.S. from $69.8 billion in 1990 to $164.8 billion in 2010. Use the midpoint formula and the two given points to estimate the revenue from fast food restaurants in 2000 and compare it to the actual figure of 107.1. I know that was a mouthful. I was just kind of going through it once. We had to read through it several times. It says use the midpoint formula. So right there, we know what formula to use. Again, every time we use a formula, it's a good idea to write it down. Okay? Every time we use a formula, it's a good idea to write it down. That helps to ingrain it into our memory. Let's see. So let's go ahead and do that. How does the midpoint formula go? So the x coordinate of the midpoint, the y coordinate of the midpoint. Okay. All right. So now let's see if we can plug in different components. All right. And increase from there to there. Use a midpoint formula. Oh, so we have a chart. So we want to find the midpoint between these 2 points, right? So what's the ordered pair here? What's the x coordinate there? What's the x coordinate there? The year. 2010, right? So the x coordinate, we're going to say, is it? Yeah, that's fine. This can be 2010, comma, what's the y coordinate there? Does that make sense? For this point, what's the x coordinate? What's the y coordinate? We want the midpoint of these two. Is that okay? Can you take it from here? I mean, just in general. I'm going to leave the rest as an exercise. So then it's also a good idea to automatically kind of do the following. We can go x1, y1. We can go x2, y2. And it'll work. Just be consistent in that labeling. All right, let's see. So we got our 2 ordered pairs. You know, we matched the blues together. We matched the oranges. We took the average of the blues, average of the y's, or average of our x's, average of the y's. Okay, and we get the following. Once you have the proper setup, then to crush the number is fairly simple. Okay, so you want to give that a go without looking at the results to make sure or confirm that you can arrive to the same conclusion. For each equation, find at least 3 ordered pairs of the solutions. So now, if we have y equals 4x minus 1 and we want a solution, what can we do? What does it mean for an ordered pair to be a solution? We're not solving. Like, what's one solution to this? What does this graph look like? If this is y equals, yeah, it's a line. 4, right? The slope is 4. The y-intercept is -1. So now we have this line that passes through -1 with a slope of 4. How many solutions are possible on that line? How many points? How many you said? There are infinite solutions, right? So what's one ordered pair when x is, give me an x? 2. When x is 2, what's the corresponding y?
7.
So 2, 7 is going to be one of the solutions or ordered pairs to this. Give me another x value. I heard 9, right? What's the corresponding y? Okay, so these are 2 solutions. We just chose the x's. We find the corresponding y's. I know, I'm like crying over here. I'm like so sleepy. I want to go to sleep so bad. Well, we got like 20 minutes in and I can kind of lay my head down for a bit. So, but these are just some solutions, right? So we just chose some x's, find the corresponding y's. In this example, we could also choose a y value, find the corresponding x. So on and so on. Okay. Anybody know what this graph looks like? Okay, yeah. If we solve for y, right? If we solve for y, what would we do? Square both sides, and add 1. We're gonna have x squared plus 1. X squared plus 1 equals y, right? What does that graph of x squared look like? It's a U-shaped graph or a parabola. Yeah. So long story short, square root is going to be the top half of a sideways parabola. Since the x and y are switched, it should be the right-hand side of a parabola. I think that's right. Square both sides, x squared. Yeah. So it should be the right-hand side of a parabola. But the square root is typically the top half of a sideways parabola. Let me see. I think that's proper. But you could graph it, but yeah, it's just gonna, yeah, I'm just not drawing it. I know it's kind of a bit much. Let me see, if I squared, let me kind of look at something really quickly. Ordered pair over 1 of 2, 0, 1, 0, 1. Yeah. It's going to be the right half of a parabola. We'll see that again in action. We'll touch on it a little bit later. All right. I feel like there's something missing. Where is it? You know, I'll let it be. So the order pair 1, 2. One order pair is 1, 2. Verify the order pair is 0, 1 and 2, 5. Right? So we could choose, we could plug in for the y, find the corresponding x, or vice versa. All right. The table provides an organized method for determining ordered pairs. So yeah, if we have y equals x squared minus 4, on the left we chose those values of x. We found the corresponding values of y. So when x is -2, y is 0, so on and so on. Okay? I'm going to let that be. I feel like this isn't that bad. Graphing an equation by plotting points. Okay, so now, if we have an equation, first technique we want to look at is maybe identify the intercepts, x and y intercepts. We want to find as many additional ordered pairs as needed, so on and so on. Okay, let's see an example. What should this graph look like? A straight line because the highest degree is what? 1, right? What's the y-intercept? -1. What's the slope? 4, right? So it should be a straight line with a positive slope of 4 passing through a y-intercept of -1. I think we just did all that verbally. Let me see. So step 1, find the intercepts, right? So if this is the original, now if we're going to find the y-intercept, or actually, what's the y-intercept? -1, right? To find the x-intercept, what do we do? Set y equal to 0. So if we set y to 0 and solve, we add and divide, we should get 1 by 4. So we have the x-intercept and the y-intercept. You see them there. Then we found some other, with just a few additional points on our graph. So we have the intercepts. But honestly, if it's a straight line, how many points do we need to create a straight line? 2, right? Does that make sense? So once we had the 2 and we knew it was a straight line, that was enough. We could just connect them with the straight line, and that was enough. Okay, I'm going to keep moving. Almost there. I'm so sleepy. Okay, so we only got a couple more slides. I think we're essentially done for this one. Now, all right, this is still doing that. I really wanted a different one. So keep in mind, you can use graphic calculators in my class. I don't mind. If we wanted to put this original in the graphic calculator, what would we need to do? If we wanted to put this, if we wanted to type it into the calculator, we need to solve for y, because x is already isolated. But you know, we don't usually type x equals. So if we solve for y, what would be the first thing that we would do? Square both sides and then square both sides. Yeah. So if we're solving for y, we would square both sides. We get x squared equals a -1. Sorry, x squared equals y minus 1. Then we add 1 to both sides. Yeah, so yeah, if we solve for y, we can graph that, and it should be the same graph. Let me see. Square minus 1. But it's only the right-hand side. We didn't do plus or minus. So yeah, anyway. Let me think about that. Let me see. Yeah, +1. Yeah, we're okay. So it's a parabola where we moved up. Another thing to do when we go to graph these, we want to be clear about the domain. So we can't take the square root of what kind of numbers? Negative numbers. We can't take the square root of negative numbers. It's almost there, don't worry. We can't take the square root of negatives, right? So long story short, that y minus 1 has to be greater than or equal to 0, right? So if we identify the domain in the beginning, or I guess in this case it would be the range, y minus 1 needs to be greater than or equal to 0 in order to be true. If we solve, that means that y has to be greater than or equal to 1. If you look at the graph, we have the domain. The range. I can identify the range. For right now, I'm going to let it be. So I know this is a little bit convoluted. You got to work it and kind of discover it for yourself. Graph this. Okay, so what's going to be the shape in this part C? It's a parabola, and which way does it move? Down by a factor of 4. So that means our y-intercept is what? -4. So it's a U-shaped graph that crosses the y-axis where the vertex is at -4. So it says plot the points and join them with a smooth curve. So they chose some x-coordinates, found the corresponding y's. Plotted all those points. Okay, I think that's enough for one day. Let me see the time. Yeah, that's exactly when I wanted to stop. Okay, so I'm going to pause for the cause there. Are there any questions or comments or concerns that you feel like our YouTubers might need to hear? If there aren't any questions, comments, or concerns, I'm going to pause for the cause there. We're going to end the session, and from one beautiful mind to another, enjoy the rest of your day. Keep in mind, this is for my students. So I think we'll be here this Friday. Monday's a holiday, so we're not going to be here Monday. Y'all not here Friday either? What school? Okay. So we won't be here Friday then. We're not here Friday. We're not here Monday, so it's going to be a week before I'll see you all. So more than likely, we won't do exam 3 when we get back. It'll probably be the following Monday over the first half of chapter 2. Is that? Yes. 2.1 to 2.4. It doesn't hurt to go ahead a little bit, but at a minimum, just focus on 2.1 to 2.4. If you ever see a study guide in my class, again, if you know for right now, just because the coordinate system and everything is kind of jammed, if you know my study guide, you should know the exam. But the study guide is not posted right now. Again, if you wait till the study guide that comes out, that's going to be too late. It's like cooking. If you want the food to be succulent and tender and juicy and flavorful, you got to start early, marinate it, and let it sit. You got to take your time. If you try to marinate 5 minutes before serving to your people, it's not gonna be the same. You know what I mean? So this is the same kind of deal. If you really want to increase the odds of your success, still there's no guarantee. You got to start now. So right now, this afternoon when you get home, go ahead and finish 2.1. You should be able to finish 2.1. You know, go ahead and I'll probably go ahead and load all of 2.1, 2, 3, 2, 4, all of those. I'll go ahead and load them all. You want to go ahead and get through them. That way, when we get in class, it should be a review at that point. When you engage me, if you're not paying attention to my class or asleep or that kind of jazz, I'm not going to wake you up. First of all, I'm going to treat you like an adult. You're an adult, so you decide. It's your decision. You decide your experience. That's not my place. My place is I'm just going to write down what you're doing and then calculate it, and that's it. That's all that I do. So yeah, again, there's no guarantee, but you're going to boost the odds of success in your favor. Go ahead and finish out this work immediately. That way, when we come back together, when I start going over 2.2, it should be a review. You should be reviewing at that point. When the study guide comes out, that should be a review. If you're trying to learn from the study guide like completely, like you wait all the way until the study guide comes out, that's a recipe for disaster in my class. And I know a lot of students do that. I don't even ask anymore. I already know what's going on. I don't check your work. I know by the way we interact. I know what's going on. I'm just not going to say anything. So again, you decide what kind of experience you want to have. If you want to increase your score, you got to team up with people that are getting it. There are people that kind of know this stuff already, so you might not want to emulate them because they already know this information. But you can get some information out of them. Do what successful people do. So just kind of ask them and see what they say. But there are people that I know are studying, that are doing their work, and that are being successful. You might want to try to be around them and say, hey, what are you doing different than I do? You mind helping me? Can I get some assistance? These kind of things. Okay, I'm getting off the soapbox. That's enough talking for me for one day. I'm going to stop there. And again, from one beautiful mind to another, enjoy the rest of your day. Any other questions? Go ahead. Yeah, so I'm going to go and get the old quizzes so you can get a copy and you can see it. There was another thing. It was the old exams, and there was something else. You said being able to log in. So you want to take this time now and make sure that you can access MyMathLab. This is a great time to go ahead and get that access. I'm not going to see you all for another week. If you don't do it now, you're going to lose a week. That's a recipe for disaster. You do it now, you're setting yourself up for success. Okay? No, that's enough. Yeah. No, I'm not doing it. No. Okay, so we're gonna stop there. But you guys aren't free, so we still got to stay together for the next 20 minutes or so. Okay, so make sure that you have access to MyMathLab, and I'm gonna go get your old exams. If anybody want to see any old exam, you can look at it. You can take a picture. We can. Yeah, we can do all that. I'm just gonna go grab them. I'll be right back. Okay. So from one beautiful mind to another, enjoy the rest of your day.